Alright, in this video we're going to talk specifically about factoring out a GCF. The overarching thing that we're doing is just factoring in general. The method that we're going to use in these examples is to factor out a GCF. Essentially, when we talk about factoring, what we're talking about is taking something large and putting it down into its parts, making it smaller. So the first thing that you need to do is you have to be able to identify what that greatest common factor is that exists with your terms. Once you figure out what it is, you have to divide it out of your entire expression, thus making your expression smaller. So there's two forms that we have of how your factors may look. The first form is where you have a single term on the outside and the rest of your expression is left inside. Or when you factor it out, you end up with two binomials side by side. Okay. Now, the one hint I can give you is that if your expression starts out with a negative term, then your GCF will be negative because you're going to pull that negative value out of the term itself. So I've got a couple different examples of all different types of expressions where we're going to be able to look at factoring GCFs out of those expressions and turning them into something a little bit smaller. So the first one here is 14x plus 21. So when I look at 14 and 21, you have to look at what is in common between them. So there's a couple ways that we can approach that. The first way is we could simply look at, say, factors of 14. So we know 1 and 14, and then we know 2 and 7. And then we can look at factors of 21. Again, 1 and 21, 3 and 7. And when we're doing that, we need to identify the largest term that's common between both. So here we've got a 7 and a 7. That is the largest term that is common. Therefore, in this case, we would say that your GCF was 7. Now, that's not actually what this problem wants. This problem wants you to factor by using the GCF. So what that means is I have to pull the 7 out. So when I pull it out, I have to look at what's going to be left behind. So first, when I pull a 7 out of 14x, what's left behind is a 2x. And when I pull a 7 out of 21, what's left behind is the 3. So plus 3. This is what we were after. So when we have 14x plus 21, that will factor down to 7 times 2x plus 3. Alright, let's do it again. So here I have negative 3x squared and I have a 6x. So first of all, if I look at my first term, I have a negative 3. So again, those factors would be 1 and 3. Obviously the negative means one of them is negative. And then on the other factor I have a 6. So again, this would be 1 and 6, 2 and 3. So if I'm looking for my greatest factors of my digits, it would be a 3 and it would be a 3. So here, what we're actually going to pull out from my GCF in this case is we're going to pull out the 3, but remember the rule says if the first term is negative, then so will your GCF be, so we're going to pull out the negative 3. Now, we also have x squared and x. So when we're looking at these, I also have to look at the fact that I have x squared, which we know reduces to x and x, and then I just have the single x. So again, when I'm looking for a greatest common factor, I would have 1x from here and the 1x from there. So that means I'm actually pulling out a negative 3x as my factor. So when I pull that out, it means I'm dividing it out of my expression. So when I pull the negative 3x out of x squared, this leaves just simply behind an x. If I pull a negative 3x out of a positive 6x, it's going to leave behind a negative sign. And then 6 divided by 3 is 2. And thus there we have it. So in this case, my factor becomes negative 3x times x minus 2. Okay, let's look at another one. So here I have 5x squared minus 15x minus 5. So again, I want to look at greatest common factors. So if I look at 5, this is 1 and 5, and that's it. I have a negative 15, so this becomes 1 and 15, 3 and 5. And then I have, again, a negative 5, so in this case I have 1 and 5. So if I identify my greatest, it would be here with my 5s. And then the other piece is I have an x squared and x, but nothing on the back end. So therefore, when I'm looking at it, my greatest common factor here is just the 5. Now with that, when I pull a 5 out, I'm left behind with an x squared minus a 3x minus 1. Now when I'm looking at this, the internal, one of the things that we have to think about is, can I factor this down any further? So ignoring the 5 out in front, is there anything I could do to make this a little bit smaller? And in this case, the answer would be no. And the reason for that is because there are no factors of negative 1 that when added together give me a negative 3. Therefore, we've actually factored as far as we can. And then my result then would be 5 times my x squared minus 3x minus 1. Okay, let's look at it again. Here I have 8m squared x cubed. So first of all, when I'm looking at all of these, one of the things I notice is that I have this m squared, and m squared in all of my terms. So I automatically know part of my GCF is going to be to pull out this m squared term right here because it shows up in all 3 of them identically. Now with that, I need to know what else to pull out. So here I have an x cubed, y, and z, so I won't be pulling any other variables out, but I have this 8, which becomes 1 and 8, 2 and 4. I then have the negative 12, so 1 and 12, 2 and 6, 3 and 4. And then I have the 4, which is just 1 and 4. Again, I need to identify. So here, in all 3 of them, my greatest term is a 4. So this actually tells me that my GCF here is going to be 4m squared. So with that, I can pull that out. So I've got a 4m squared on the outside. And then I have to look at what's left. So when I pull a 4 out of my first term, I've got a 2x cubed left over. If I pull a 4 out of my middle term, this leaves me with a negative 3y. And then if I pull a 4 out of my last term, this leaves me with plus z. Now, in looking at this, there's nothing else for me to do because all of these variables are completely different. Therefore, I'm completely finished. Alright, let's look at just a couple others. And the reason for these is because they look slightly different. Again, the rule or the name of the game is to factor everything out as far as you can go. So here I have negative 56 x to the 4th z cubed minus 98 x cubed z to the 4th plus 35 x squared z to the 5th. So first things first is we need to identify which variables are being pulled out. So I have an x, an x, and an x. So remember, when we're talking about greatest common factors, we want the smallest exponent. So I have to the 4th, to the 3rd, and squared. So what I'm actually pulling out is the x squared. I still have the x and I still have the x. Now the other piece is I've got these z's here, so I've got this z cubed, z to the 4th, and z to the 5th. Again, I want to pull out the smallest, so I have 3, 4, 5. The smallest here is going to be my 3. And then last I have my actual digits. So my 56 I can break down. So I have my 1 and 56. I then have 2 and 28. So I've got my 2 and 28. I then also have 4 and 14. And then I have 7 and 8. When I'm looking at 98, again, I've got 1 and 98. I have 2 and 49. Seven and 14. I think that about does it for that one. And then with 35, I have 1 and 35. And then I've got 5 and 7. Alright, so when I'm looking at these again, I want to have the greatest value that's in common with all of them. So I have a 7, and a 7. So here, if we put it all together, it says that my greatest common factor is going to be made up of 7 x squared z cubed. Now the other piece that I want to do with it is I need to recognize that I've got this negative out in front. So I need to slap that negative into my greatest common factor. So when I pull that out, so my negative 7x squared z cubed, I have to look at what's left. So my sign for this first one is going to turn positive, and when I pull a 7 out, 8 is behind. So this is going to end up being an 8. I'm pulling out 2 of my x's, so 4 minus 2 leaves 2 behind, and I'm pulling out 3 z's, so the z goes away. I pulled out a negative, so that changes my sign to positive. And then when I pull out 7, I leave 14 behind. Again, I'm pulling out my 2 x's, so there's 1 x left behind, and I'm pulling out 3 z's, so there's still a z left behind. Last but not least, my sign now turns negative. When I pull a 7 out, I leave behind the 5. I need to pull an x squared out, so it goes away, and I'm pulling 3 z's out, so this becomes z squared. And thus, there we have it. my new factored term. Now again, the reason why I know that at this point I'm not going to really go any further is because my variables are different and none of them are perfect squares. Alright, last but not least here is this one. So again, we have to identify that greatest common factor. So notice in both of these I have this x squared plus 1 binomial. So in all reality, my greatest common factor here is actually going to be the binomial x plus 1. So when I pull that out, this becomes on the outside. What's left on the inside is going to be the 9x minus 1. Now the reason for this minus 1 here is because of this sign right here in the middle. This still is there, so when you pull the x plus 1 totally out, you leave behind itself, or 1. So there you have it. That is, in a nutshell, everything you need to know in order to get started with looking at factoring by greatest common factors. So if you have any questions, please let me know. Otherwise, I hope you enjoyed yourself. Remember to smile, have lots of fun, and I'll see you next time.